All right, in this video, we're going to talk about how to plot points in the polar coordinate system. So here we have some points, and we'll just go through and kind of plot each one of those. So the very first one would be -2 pi over 3. All right, so normally when you're plotting points in the Cartesian coordinate system, most of the time it seems like people kind of go do the first one first and the second one second, and or deal with the second coordinate second. But when you're doing the polar coordinates, plotting points in the polar coordinate system, it's better off to do the second one, the angle, first. Okay. So in this one, I have -2 pi over 3. So what you want to do is find pi over 3, right? So imagine starting here in this position, sort of the 0 position, and you want to rotate out to pi over 3. Okay. So pi over 3 would be somewhere in here. It's hard to get it exactly on that, so I'll just set it to pi over 3. So we think about rotating out right here to pi over 3. Okay? And so that's the very first thing you want to do. Whatever that second coordinate is, think about an angle, right, whose terminal side is at that position. And now, on this one, right, we can see the first coordinate is a -2. So what you want to do, right, is now that you've got the angle set, you want to think about standing here at the origin and then walking 2 units in this direction if it were positive. But however, it's negative, so you want to think about walking in the opposite direction that that ray is pointing. So on here, on Desmos, I have it so that I can just kind of see a little bit easier what the opposite direction is. So you want to go directly in the opposite direction. So that would be down here along this dotted blue line. And I want to walk for 2 units in that direction. And I'm going in the opposite direction because the r is negative. So the point -2 pi over 3 is going to be located right here. And so in Desmos, I have a little setup to easily plot polar coordinates. It doesn't do this by default that I know of, right? So there is where the point -2 pi over 3 would be located. Okay, so again, I rotate out pi over 3 units, and then because the r is negative, I walk 2 units in the negative direction. Okay, so you got to be careful on Desmos, even if you are in the polar grid. If I do just enter the point -2, 3, it's going to give you where that -2 point, where the point -2 pi over 3 is located in the rectangular coordinate system. By the way, on Desmos, you can switch by clicking this button right here. So you can see that's at -2 pi over 3, which is about 1.7 around in there. No, a little bit bigger than 1. Let's see. It actually shows it to exact value there. So you got to be a little bit careful. I have this set up so that if I put the capital letter P before the point, it shows it in polar coordinate system, or it plots it in the polar coordinate system. So that's where that one is at. Okay, next point is at -1 minus pi over 2. Okay, so what I'm going to do, right, is again start with the negative pi over 2 first. And I'm going to find the angle, right, where the terminal side would be for minus pi over 2. So that's if I rotate pi over 2 radians, right, in the negative direction. So I'm going to rotate right around in here. And it's kind of around minus 1.5. To get it right on there, right, I would have to do it as minus pi over 2. All right, so I think about that direction right there. All right, and so then next up, right, the r is -1. So again, I wouldn't walk in this direction that the ray is pointing. I would walk in the opposite direction, -1 units. And so that would be this point right here at -1, where the circle, with radius 1 would be. So walk in the opposite direction. So that would be P -1 minus pi over 2. Right, and so there you can see where that point's located. So rotate -pi over 2 units. It's pointing in this direction. The negative one says walk in the opposite direction, a distance of 1 units. Okay. All right, next one is 3 negative 7 pi over 4. Okay, so negative 7 pi over 4. So let's see. So 3 negative 7 pi over 4. So I would rotate and do the rotation first. Negative 7 pi over 4. So now 7 pi over 4, right, is almost all the way around. If you rotated positive 7 pi over 4, you'd rotate all the way around over here. And so it would be pointing down here. But we're rotating in the negative direction, right? So we would start rotating. That would be pi over 4. Minus pi over 4 rather, minus 3 pi over 4, minus 5 pi over 4, all the way around to minus 7 pi over 4, right around in there. So that's the direction that we would be pointing. So we rotated minus 7 pi over 4 units. And then here the r is positive. So what we would do is imagine standing here and walk out 3 units on the ray, right? And so that would be halfway between 2 and 4. So right around in here is where that would be. Okay, so that point is 3 negative 7 pi over 4. Okay, so right in there. All right, next point is negative 4 pi over 3. Okay, so again, I'd start back at 0 here. And then I'd rotate to pi over 3. So pi over 3 is right up here. Okay, so that's the direction I would be thinking about. And in this case, the r is negative 4. So I'd walk in the opposite direction, right? So in that direction right here, a distance of 4 units. So that I would wind up right here in the polar coordinate system. So that would be negative 4 comma pi over 3. And there you go. Okay. All right, next one is 5 pi over 2. So again, start back here at 0 and rotate out to pi over 2, which is right up at the top. Oops. So right up at the top, and that's the direction that I would be pointing in. And then looking at the r, I have an r of 5, so I would walk in the direction of that to 5 units. So again, that would be halfway between the 4 and the 6 here. All right, and so that's where I would wind up. P of 5 comma pi over 2. So right up here. Okay, next example is 0 to pi over 3. Okay, so again, start at 0. And I would rotate out to 2 pi over 3, right, which is right up here. So rotate out to 2 pi over 3. That's the direction, right? And then I think about standing here at the pole, and I'd walk 0 units in that direction. Well, if I'm standing at the pole and I walk 0 units from the pole, right, then I'm going to be directly at the pole, right? So here, because the r is 0, it's going to be directly at the pole. So 0 comma 2 pi over 3, and that's where that point is located right there. All right, next example, 4, 0. So I'd start at 0. Okay, and so on here, I would rotate out 0 radians. So that's the direction that I'm pointing. And then in this case, my r is 4, right? So I would walk 4 units in that direction. I would wind up right here. So the polar point 4 comma 0 is right there. Okay. All right, and finally the last example is minus 4 pi. Okay, so I would rotate pi units starting at 0, rotate out to pi units, and that would be right here on the other side, right, of the unit circle. Okay, so that's the direction I would think about that the angle is pointing in. And then I would walk -4 units. Okay, so an r of -4, what that means is you don't walk in the direction that the angle is pointing, but you walk in the opposite direction. If I walk in the opposite direction, then I'm right here at this point again. So right there, that's something a little bit odd and something to think about whenever you're using polar coordinates is that I can have polar coordinates that look different, but give me the same point. So you can see this point over here has polar coordinates for 0, but it also would have polar coordinates -4 pi, right? So that's one thing that is different from rectangular coordinate systems, or I should say another thing that's different from the rectangular coordinate system is that polar coordinates are not unique. With rectangular coordinates, right, if I give you an xy, then an ordered pair, then it corresponds to a unique point in the Cartesian coordinate system, right? And if I have another ordered pair that corresponds to that same point, well, that means that the first coordinates and second coordinates have to be equal to each other. But here you can see this point 0 and -4 pi, right? They correspond to the same point, but -4 and 4 are not equal, and pi and 0 are not equal, right? So that's something that takes a little getting used to in the polar coordinate system, is that polar coordinate representations of points are not unique. In fact, right, the real story is that there are infinitely many of those things. So that's something to be careful about, okay? All right, so a recap for plotting points in the polar coordinate system. Number 1, find the terminal side of the angle theta in standard position. So start with the second coordinate and then rotate out the terminal side until you get to the angle that corresponds to whatever this is, theta here. And then if your r is positive, you move in the direction of that terminal side, however many units that is. If the r is negative, though, you move in the opposite direction of the terminal side of the angle theta. And wherever you stop, that's where the point is located. And then the other thing is that if r is 0, right, then that point is the pole itself. Okay? All right, in the next video, we will start talking about how to convert points between the rectangular and Cartesian coordinate systems.